will need for this build are 4 geared motors and a chassis. As you can see here, I have already done some prep work with the motor terminals, which we will talk about in a bit. A PowerMax 20D dual channel brushed ESC, motor brackets suitable for Johnson motors, M4 nuts, bolts and washers for connecting the brackets to the chassis, M3 screws for securing the motor to the bracket, appropriate tires along with the suitable adapters and screws, a 2200 mAh 3-cell LiPo battery, an RC transmitter and receiver. For this project I have used a FlySky i6X. Some tools like a screwdriver and an Allen key, and some zip ties. Let's start the build with the chassis and the motor. We will need 2 motors per side for this robot. The motors have been connected in such a way that the left motors share a supply line, and the same is the case for the right motors. A bullet terminal is used to connect each side. Take a motor bracket and align it with the mounting holes on the chassis. Now attach the bracket using M4 nuts and bolts. Repeat this step for all brackets. The motors I am using are 12 volts 600 rpm Johnson motors with 6 mm output shaft. For the chassis I am using a pre-cut polycarbonate sheet, although you can also use an aluminium sheet in its place. Now align the motor mounting holes with the brackets and attach it using M3 screws. Be sure to attach the wires in such a way that the motors on one side should share a supply line. The motors themselves have a polarity which can be seen at the terminals. Please maintain the correct polarity for each motor. Attach the hex adapters at the end of the motor shaft using the appropriate Allen key. Now let's do a quick test for the PowerMax ESC. Attach the battery to the ESC and check out the light pattern. Be sure that the polarity is correct. The blue and the red lights should glow alternatively. Now disconnect the battery. The next step is to bind the transmitter and receiver so that they can communicate with each other. To do this, first use the black jumper provided to any channel apart from 1 and 2. Here I have connected it to channel 5. Now connect the ESC signal connectors to the receiver on channels 1 and 2 as shown here. The white wire should be facing the label side. Now attach the battery and notice that the red light blinks on the receiver. Take the transmitter and make sure the left joystick is at the bottom position. Switch it on while pressing down the bind key on the left side. Now you can let go of the bind key and wait for 5 to 10 seconds. Switch off the transmitter and switch it on again. The red light on the receiver should turn solid. This means that the binding is complete. Now you can turn off the transmitter and unplug the battery from the ESC as well. Also take off the jumper that we used earlier for binding. Now let's move on to the rest of the robot assembly. Attach the battery to the chassis. I have used reusable zip ties and secured the battery using the pre-cut slots on the chassis. Also secure the ESC to the chassis along with the receiver. Be sure to manage the wires well so that they don't get pulled while the robot runs. Attach the motor connectors to the ESC output terminals. Next, attach the battery so that the ESC comes on. I prefer to do this step without the wheels so that the robot does not move in case the motors start rotating unexpectedly. Let's take a look at how the robot works with the transmitter. When I move the right joystick on the vertical axis, one side starts moving and the other side moves with the horizontal axis. This isn't the ideal case since we are trying to control a robot. To change this, we will have to change some settings on the transmitter. Press and hold the OK button for 2 to 3 seconds till you see the settings option. Now press the up button to access the function setup and press OK to access this setting. Scroll down till you see the elevon setting. Press OK to enter that. Now press the up button to change the elevon off to on. Press the OK button to access the channel 1 setting and change it to 100% by pressing the up button. Repeat this for the channel 2 as well. Once the settings have been changed, you have to long press the cancel button to save the setting. Short press the cancel button to go back to the home screen. Now when you test the transmitter, you will notice that the motors on both sides respond to the joystick command together, which is what we want for our robot. We will now attach the wheels onto the adapters. Align the wheels with the adapters and use appropriate screws to secure them in place. Now test the robot and make sure that the robot moves in the correct direction as per the joystick inputs. If you notice that the motors turn in the opposite direction when you use the joystick, you can again go to the settings on the transmitter and enter the reverse setting. Here make channel 1 and 2 as reverse. Another issue that you may face is The forward and the back move as expected, but the left and the right directions are switched. For this, you can interchange the signal wires on the receiver. Interchange the first and the second channels on the receiver, and the robot should now move as expected. I hope you found this video helpful, especially for those of you who are looking at how to use a brush DSC and trying to make the transition from a wired robot to a wireless one. Thanks for watching.